NeuroGov Python Framework with all 63 engine modules. A modular enterprise AI engineering framework for intelligent, governed, secure, and scalable artificial intelligence. Introduction. The NeuroGov Python framework represents a modular software architecture designed to implement enterprise artificial intelligence through 63 specialized Python engine modules. Instead of relying on a single monolithic application, the framework distributes intelligence across independent yet interconnected components, allowing organizations to build AI systems that are scalable, maintainable, governable, and adaptable to changing business requirements. The framework follows a modular engineering philosophy in which every capability is implemented as an independent Python program. .py. Each engine performs a specialized responsibility such as data acquisition, machine learning, governance, analytics, security, reporting, orchestration, or enterprise integration. Together, these modules form a coordinated enterprise AI platform capable of supporting complex digital transformation initiatives. The Python ecosystem provides a practical foundation for this architecture because of its extensive support for data engineering, machine learning, deep learning, natural language processing, computer vision, automation, cloud computing, and enterprise integration. By leveraging mature open-source libraries together with modular software engineering principles, the framework enables organizations to accelerate AI development while maintaining governance and operational control. Unlike conventional AI solutions that focus primarily on predictive models, the NeuroGov framework emphasizes the complete enterprise AI lifecycle. It integrates knowledge management, retrieval augmented generation, RAG, long-term AI memory, explainability, responsible AI, governance, policy enforcement, monitoring, deployment, and executive dashboards into a single architectural model. This approach recognizes that enterprise AI success depends not only on intelligent algorithms but also on governance, reliability, transparency, and operational excellence. RAG, retrieval augmented generation. Definition. Retrieval augmented generation, RAG, is an AI architecture that enhances the capabilities of large language models, LLMs, by retrieving relevant information from external knowledge sources before generating a response. Instead of relying solely on the model's internal training data, RAG combines information retrieval with generative AI to produce more accurate, current, explainable, and context-aware outputs. The 3D, 10D AI-DNN engine is an enterprise cognitive intelligence architecture proposed by Dr. Pradeep K. Suri as part of the NeuroGov Advanced AI Enterprise framework. It extends conventional deep neural network concepts into a multidimensional enterprise reasoning model, enabling AI systems to integrate knowledge, governance, analytics, contextual reasoning, risk assessment, decision intelligence, and organizational objectives within a unified cognitive framework. Unlike traditional deep neural networks that primarily learn statistical patterns from data, the 3D, 10D AI-DNN engine is designed to support enterprise-scale intelligence by combining multiple dimensions of reasoning with governance-aware decision support. The architecture is organized into logical capability groups, beginning with foundational data acquisition and processing, followed by intelligent reasoning and decision support, governance and compliance, enterprise services, analytics, infrastructure management, deployment, and continuous innovation. Each engine exposes clearly defined interfaces that simplify integration with other enterprise systems while enabling independent development and maintenance. A key advantage of the framework is extensibility. Organizations can enhance individual engines, introduce new modules, or replace implementations without redesigning the entire platform. This modular approach reduces technical debt, supports continuous improvement, and aligns with modern software engineering practices such as microservices, containerization, DevOps, and MLOps. The framework also promotes interoperability by supporting standard communication protocols, enterprise APIs, cloud services, relational databases, vector databases, knowledge graphs, and distributed computing environments. As a result, It can integrate with existing enterprise ecosystems rather than requiring complete infrastructure replacement. Governance is embedded throughout the framework rather than added as an afterthought. Dedicated engines for policy management, responsible AI, explainability, risk assessment, compliance, auditing, authentication, authorization, and security provide mechanisms to help organizations build AI systems that are accountable, transparent, and aligned with organizational objectives. From a development perspective, every engine is implemented as a dedicated Python module with a clearly defined purpose, associated libraries, supporting classes, configuration files, and interfaces. This consistent structure simplifies collaboration among software engineers, AI specialists, enterprise architects, and operations teams. Ultimately, the NeuroGov Python framework serves as both an engineering reference architecture and an implementation blueprint for enterprise AI systems. Its 63-engine modular design demonstrates how artificial intelligence can be organized into reusable, governed, and production-ready software components capable of supporting organizations across diverse industries. Summary: the NeuroGov Python framework illustrates how enterprise AI can be implemented as a coordinated collection of specialized software modules rather than as isolated algorithms. Each of the 63 Python engine modules contributes a distinct capability while working together through standardized interfaces and enterprise workflows. The framework combines modern Python technologies with governance, security, explainability, analytics, orchestration, and deployment practices to create a practical architecture for enterprise-scale AI systems. Its modular design encourages reuse, extensibility, maintainability, and interoperability, making it suitable for organizations seeking a structured approach to responsible AI adoption. By integrating engineering discipline with artificial intelligence, the NeuroGov Python framework provides a comprehensive foundation for building governed, scalable, and future-ready enterprise AI platforms. Power Summary: the NeuroGov Python framework transforms enterprise AI from isolated machine learning projects into a comprehensive engineering platform composed of 63 specialized Python engine modules. Each module performs a dedicated responsibility while collaborating with the others to create an integrated AI ecosystem. The framework spans the complete enterprise AI lifecycle from data acquisition and processing through knowledge management, cognitive reasoning, governance, analytics, deployment, monitoring, and continuous innovation. By combining modular software engineering with the Python ecosystem, it provides organizations with a structured approach to building scalable, secure, explainable, and maintainable AI solutions. Rather than concentrating intelligence in a single application, the framework distributes functionality across independent modules, making development, testing, deployment, and future expansion significantly easier. This modular architecture supports enterprise governance, operational resilience, and long-term sustainability while enabling organizations to adopt new AI technologies as they evolve. About Dr. Pradeep K. Suri. Dr. Pradeep K. Suri is an Indian technology researcher and enterprise AI architect whose work focuses on the engineering, governance, and practical implementation of enterprise artificial intelligence. His research explores how modular software engineering, AI governance, decision intelligence, knowledge management, and responsible AI can be combined into unified enterprise architectures. He is the architect of the NeuroGov Advanced AI Enterprise Framework, a modular enterprise AI architecture centered on specialized AI engines that collectively support data engineering, cognitive intelligence, governance, analytics, automation, enterprise integration, and executive decision support. His work emphasizes the importance of building AI systems that are not only technically capable but also transparent, secure, explainable, and aligned with organizational governance objectives. Through the NeuroGov initiative, Dr. Suri advocates an engineering-first approach to enterprise AI in which reusable software modules, standardized development practices, and governance mechanisms work together to support scalable and sustainable AI adoption across industries. Dr. Pradeep K. Suri.